the second. Okay, so let me just go straight in here. Grimy Defiant trial software. Okay. So remember, there were two types of higher order functions, right? Higher order functions. And the first one was a function that takes another function as an argument, and then a function that returns on another function. This is what we're going to focus on. Oh, you can't see the typing. Let me reshare here. Oh, you could see it? Oh, okay. Yeah, I sometimes have trouble seeing screens, so you can refresh if you need to. Like sometimes when I like join, um, like the breakout room, I like don't see the screen. So, so yeah. So this is what we're gonna focus on, right? A function that returns another function, not a function that receives like a callback, but a function that returns a function. Okay, and so this kind of now you whoa wait, what? Whoa, what? I didn't even press anything. Now it's just black. All right. Let me refresh. Okay. No, it's not. It's definitely not you. Something's going on with Zoom. Okay, you can see it now. All right. Today is weird. Like, sometimes I feel like there's just like these invisible forces that just sort of something's just going against the grain right now. Um, so a function that returns another function, and this kind of goes along the idea of functions as first class citizens. In other words, functions are just things like anything else. This is the less official definition of what a first class citizen is. It's just a thing, right? Shouldn't have raided that tomb last night. I know. Dang. I like didn't believe in the curse at first, but um so what does this mean, right? I can have a function that uh cool, because I just can't think right now. So this can return 5, right? This just literally returns number 5. And so I'm going to say let result equals cool, and I'm going to console log result. Okay. What is result? What is it going to be? 5. Exactly. Okay. Because this function, right? When this returns 5, the way you can think about it is really when you like execute this function just kind of like becomes 5, right? I know that's sort of like a weird visual, but calling this function will execute this, right? And so if it's console log, I'll say like calling cool, right? So execute this, okay? And then it'll return 5, which means the result of this is 5. So it's like, it's really as if I just sort of like, it's as if I just did result equals 5. Let result equals 5. Okay. And similar thing, right? If I copy this and maybe return a string, hello world, okay, then what is result? Result is hello world. Okay, so this came out of this function, and then kind of took the place of cool. Okay, and now there's a result. Any questions so far? Cool. And then I know this is just like kind of beating a dead horse, but if this is like an array, right, that has hello and world in it, let me just get rid of this. This array is going to be returned out of this function. Okay, so this kind of generates this array, and we stick it into result, and now result is this array. So anything that's returned out of this function will be stored into result. Okay, anything. And we're going to kind of use that knowledge, right? And then also combine it with the fact that functions are first-class citizens, right? To basically return a function. Okay? So instead of returning an array or a string or a number, we're going to return a function because a function is a thing, right? And I'm just going to do, again, just literally the simplest function, right? This is the function. I know it doesn't seems like it like can't be possible, but this is actually a function. Okay? And so I return this. So this function runs. It returns a function. And so what is result? What is result going to be? It's going to be a function. It's not going to be cool. It's going to be this thing. This is the function, right? It's a function. This is the function. So again, like in terms of just like kind of copying this and like pasting it here, right? Or like if I were to take this array and I were to say, it's like saying result equals this array, right? What we basically did here was I took this function and I'm saying result equals this function. And suddenly, like, everything becomes clear. Like, oh, yeah, of course, result is a function. That looks like a function to me. The result is a function. And you can literally think about it like this. There's nothing wrong with thinking about it like this. In the same way that, again, if this thing returns, like, 500, right, you can think of this, okay, this function runs, and I put 500 here, great. But, like, you can also just think of it as, like, okay, I'm just setting result to 500. So if I console log result, of course I'm going to get 500, right? Because that's literally what result is. So that's what's happening here. Is we get this function. So really cool when run is a function. Like it will return a function. Okay. Right. That right. That's a good question. I think it's because yeah, that's a good question. I'm not sure. I think it's just like it's one of those things where you have to run it to find out. Like and by default it's sort of like in its off state. And because it's off, it doesn't like go through the trouble of revealing what's inside of that function, right? Until you run it. But yeah, I don't have a great explanation other than that. So okay, so let's have this function actually like do something. Okay, so this is gonna return a function, and this function is going to console log. This is very weird. Okay, what will we see if I click run here? Trick question. What are we gonna see? Function. Are we gonna see this is very weird? Because we didn't call it. Wonderful. So we only see function, right? So this thing, like it's at okay. So this thing that I did here, right? It's as if I did this. it's as if I did this, because this is the function that's being returned from cool, and therefore like I'm just kind of replacing this with this, right? And if this were the case, and I just have this function, and I just console log the function itself, like that doesn't do anything. Interestingly, it actually has a name now, but it doesn't actually console log. This is very weird, because really what we're saying is, here's a blender. What is this? Oh, it's a blender, right? When you ask what is this thing, and that thing is a blender, is the act of asking gonna turn the blender on? No, right? It's continues to stay off because we never called the function. We never called the function. Oops. So coming back here, we call cool. Cool returns this function. That function is stored into result. So now result, like think of like literally like this inseparable connection between result and this function. Just sort of like try to like ingrain in your mind that result and this function are the same thing. Result is this function. Okay? So if I console log result, that's just the function, and then so to run it, I call result, because again, result is this function. Cool. And now we can kind of, again, just using what we know about functions, right? We can have this accept the variable, so like name, okay? And we can say this function is, we'll say like name, isn't this very weird? Okay. So, okay, one more time. This function is this function. Okay? That's how you should visualize this. Result is this function. So when you call result, you're calling this function, right? You're calling this function, and so you have to put in a name in here. So you have to put in a name in here. Okay? Say Olivia. Okay? And it's very, very paramount that you sort of separate the idea that this function is like cool, right? Cool is this function, this outer function, this higher order function. That's what cool is, okay? And cool happens to return a thing, and that thing is a function, right? And that function is stored into result. This function is not cool itself. This function is just whatever this cool returns, which is this thing, and we put into result. So when I execute result, what I'm executing is not cool. I'm executing this inner function. And that's also why I pass in Olivia into this result and not into here, right? This is a common mistake. This doesn't make any sense because this function, cool, is here. And you see that this function doesn't actually take any arguments, right? So if this doesn't take any arguments, we shouldn't be passing anything in here. The function that we should be passing something into is this function. And what is that function? That function is result. And so result is where we should be passing something in. Okay? Any questions? Yeah, it's weird. Seriously, and like I know this is like very like this just looks weird, right? Like what are we looking at right now? So definitely ask if you have questions because it will get a little more involved. Okay. Let me just do this one more time. And I'll put in Christelle. And I'm going to get rid of this one. Okay, so I'm going to console log here. I guess like inside cool. I'll say like cool. I'll just do it like this. Something like this. Alright. So I put this console log here. How many times are we gonna see this thing show up on the screen? Zero is a good guess. It's a great guess. In fact, it's almost right. So this console log cool, right, is going to happen when? When would this trigger? When I call cool, the function. When do I call cool? 41. How many times do I call cool? Once. Exactly. Exactly. So I know this is like it wasn't easy to guess, right? But like it should be easy to understand why this is the case, because this console log only logs when cool is called, right? Because I mean, just pretend like this doesn't exist, right? Like when would this ever run? When you call cool, right? And so we see this here, okay? And then you might ask like, well, okay, I'm there's this inner function that I'm like calling a bunch of times. Like, why don't those things run, right? Why doesn't it also run cool in here? Because again, result is this function, right? And because it's this function, right? Imagine just like just do this. Just think of it as like let result equals this, like this. This really is how you should visualize it. When you say result equals cool, result is this. That's what we're looking at here. And if you look at it like this, right? Like cool isn't anywhere in here, right? The function we're running is this, and nowhere in this function is there cool being logged out, right? So does that make sense? Like it should only you should only see cool at the very beginning when you're like initializing this function, when you like call the higher order function. But once you get this like inner smaller function back, then like that's the only thing that should work at that point. We're not like recalling this thing. Does that make sense? Can we do another example? Yeah, definitely. Um, are there any questions here? Don't get it? So don't get why only okay. So how can I, let's see. So like this so this here that I'm returning is sort of like, you can think of this as like x. Okay? What do I mean by that, right? So let's say there's another function. Cool. Also, I'm really glad you said like I don't get it, because probably you're not the only person who doesn't get it, right? Um, and so this is gonna help a lot of people. So I'm gonna return like 5. Okay, or this is like x. Okay, so I'm literally just gonna let me just return x, and then I'll say let result equals cool. Okay, so what is result? What did I just do? Result equals x, right? So console log result, it shows cool because I actually ran cool, and then I put x into here, so now result is x. And then let's say I do like console log like result plus like y, and then result plus z, and result plus w. So looking at this, does this, in this particular scenario, does it make sense why cool only console logs a single time? Kimberly, you're definitely described it well, and I'm gonna use that. Um, in this example, do you see why, like, so you're console logging result 3 times? Yes, so I'm console logging result 3 times, right? But cool only like console logs once, right? Like I'm not gonna see like cool, right? Because what am I doing? I'm just like taking this result. What is result? Result is the letter X, and by that point I've like, imagine I like took the letter X and I just ran away. I like ran away to, like, I don't know, like the across the street, and now I have this X. Now I can do whatever I want with X, okay? And whenever I like do anything with X, right? I'm not associated with cool anymore. Like cool's gone. Like just because I like it, sort of like, I don't know, like if you go to like a vending machine and you get a soda, you get the soda, and then that's your soda now, right? And whenever you like, if you drink the soda, if you do anything, you're like, it's sort of like separated from the vending machine. That's just like far away now, right? And it's not gonna like come back to haunt you or something. Okay, so this thing, right? Result doesn't actually equal cool. It equals what cool returns exactly. So when I call cool, right? What actually happens is, yes, this console logs, this runs, and then this function returns x. And so really this is just x right here. That's what I'm doing. So like, just so if you see the word return, just look at everything after the return and just stick that right into the variable that you're assigning it to. That's another way you can think about this. Whatever a function returns, that function becomes when invoked. Cool is x. Cool is x. Or cool parentheses becomes x, right? And so now when I do anything with x, like, that's my x. No more cool. I'm just messing with it, okay? So back to here. Here, this is like my vending machine, and it returns this thing. Okay? It returns this thing. And it's as if I returned a string x. It's really like, you can think of it as literally as that. So if I return this thing, right? What I basically did was I said let result equals this. This is the equivalent, okay, of what I just did. And so result is this function now. So if I run result, right, it only runs this function, and nowhere in this function are we console logging cool at any point. Right? And so that's what this is. So I execute cool. Basically, like, I don't know, I guess like the vending machine turns on and it spits this back out. And we're like, thank you, right? So we take this and we just run away. For some reason we run away, right? So this function is assigned into result. Now result is this function. So just look at what I've highlighted. Only that will run whenever I execute result. Only this highlighted portion will run when I execute result. Is this console log in the highlighted portion? No, it's not. So we're not running that. We're only running what's in here. Only running here. This part. That is what happens when we call result. Cool only happens once at the very top. As Kimberly said, right? When this happens, right? Yes, I'm calling this cool function. So this just runs from top to bottom, right? We console log cool, right? And then we return this function. Okay, but and then so once we're done running the function, like this function, which is what's returned, it's like sort of like what I get delivered. That this function is now mine, and I can call that function using result. Okay. Um, this function is now mine. I can call that function using result. And so when I like invoke result and put arguments in here, I'm really calling this function, not this thing. Can you call the inner function without doing this? That is a great question. That's a great question. And the answer is yes. So the first time it's called, it runs through the whole cool function, and to find the other function, then stays on that function. Yeah. So, um, I guess like think about what literally is like spit back out from the function, and then like sort of, and then now it's yours, right? So, um, like this is a function that like console logs cool and then just like spits back out x. So now you have this x, you store it into result, and now you can just like mess with it, right? Do whatever you want. But like these three lines are like strictly independent from this function itself. Because like all like now just laser focus on this letter x. Like that's yours. That has nothing to do with cool. That has nothing to do with this console log. That's just like your thing, right? And that thing just happens to be in result. Okay. Now instead of the letter x, right? The thing that I receive from the function is this function. This function just like kind of comes out, right? This is delivered, and I take this function, and that's delivered into result. So afterwards, after this fact, result is really just this function here. So anytime x equals function, it's going into a function to find a function, and then maybe I'm thinking this too much. There's multiple functions in set function. What if there's multiple functions? Great question. So what if there's multiple functions? So before we get to that, let's I'm gonna answer Olivia's question real quick. So let's simplify this. I'm just gonna do this. So let's see. So this runs this, right? The question was, is there a way to call this inner function without storing it in another variable? Right? So so we agree that result equals cool parentheses. Right? Result equals cool parentheses. So in theory, I should be able to take this and replace it here. Okay? Let me just explain this super simply, and then we'll see what I mean. Let's say num1 equals 500, okay? And let num2, or let's do this. I could say num1 plus 100, okay? Which is 600. Or I could say, what is num1? Num1 is 500. So I should be able to just do that, right? Because I mean, I'm just taking what it is and putting it here. Same answer. And I could say let string equals hello, and I could say string bracket 0, which is going to be h. Or I can do, what is string? String is this, right? I could do this bracket 0. this is also totally fine and legal. So what I'm doing is, if I see that a variable is equal to a certain thing, I can just, in theory, I can just replace that variable with that thing. So that's what we're going to use here, is if we all agree that result is this thing, then I should just be able to, like result is this thing, like they're interchangeable. That's what that means. In the same way that I was just flipping out between num1 and 500, just putting cool here. Okay. And now it calls the function. It calls this function. Like, how is this possible? Because cool is this function. Like, cool literally is this function. Okay, so if that's this function, then how do you call a function? You just put parentheses afterwards, right? And then if it's literally this function, then what do we know about this function? It accepts a name, so we can just put a name in here. So this thing is this, yeah. Yeah, exactly. Yeah, that's exactly what, what we've been sort of stressing from the beginning, right? Like something like this, if I have a function that returns the number 5, and I call that function and I assign it to a variable, really what I'm doing is like, I'm just saying, okay, what does this return? Look at everything to the right of the return. That, just stick that right in the variable. So result is 5. And like, this is one way to visualize why console logging result gives 5, right? When we first did this example, it was very obvious why this gave 5. Why is it obvious? Because cool, when run, returns 5, and that 5 is stored into result. So really, you can think of it as like cool, parentheses, and the number 5, they're like interchangeable. They're basically the same thing. And same thing with here, right? If this cool returns an array, it's as if I just did that. Like I can do that, right? I'm just skipping a step, okay? And so of course result will be the array that's returned from this function. Correct. So the reason it's more common to see it this way is because of this. Let's say I wanted to, this is actually a really good question. So I'm gonna bring this down, and I'll show you the difference. Okay. So remember earlier we did result Olivia, and then what were the other ones here? Here it is. So earlier we saw cool printed out, and then we saw this inner function run 3 times. So that's what's happening here, right? Now notice the difference when I do this. So instead of storing it in a variable and then just like calling that variable, see what happens when we do this. Amazing. That was an amazing, yeah, foresight. Cool prints out 3 times instead of just once. And this is another kind of like, a piece of evidence that shows that we will only see cool logged for as many times that we actually call cool, the function, right? We only saw cool once in the beginning. Here we're literally calling it 3 times. So we see cool log 3 times. Okay? So the end result is the same, right? The end result is we get these 3 logs. Same thing we saw here, except this up here is like more resource sort of optimized. So this is more resource optimized. This is like suboptimal resourcing, and the reason is because I am basically initializing this function every single time, the higher order function every time, just to get to this inner function, rather than storing this inner function, like running this once, storing that in a variable, and then just using that variable. The best analogy that I can think about the difference between these two is like, this is sort of like I turn on my computer, and then I'm like going to these websites, right? So I turn on my computer. What is that? That takes like 5 minutes. I see my welcome screen. I type in my password, whatever, and I just like visit these websites, right? Here, what I'm doing is I'm turning on my computer to go to this website, and then I'm turning on my computer again to go to another website, right? And then again. So like, you basically want to do that hard work once, and then use the result of that, as many times as you want. This is some freaky stuff. Any questions? Definitely, definitely. No, there's no example, and this is just like purely theoretical. um, for sure. I get it now. Awesome. Great. I'm glad you do. And if you still don't get it, that's also fine, right? This took me a long time to understand. So yeah, I'll definitely show you where this is useful, okay? Just before I do that, let me show you something else that's theoretically not useful. Um, do you remember like our whole like deal with scope, right? So let's see. Um, hmm. Uh, I'll use the variable car here. I'm gonna say let passenger. Hold on. What what's a number that we can use that like relates to a car in terms of like how like how many like what's something that has a that like piles up in your car that has like a number associated with it, like inside your car. Um, I don't know. Water bottle. I was just thinking that water bottles. Great. Water bottles is 0. Okay. Um, okay. I know this is like really random. But out here, if I want to console log water bottles, we get water bottles is not defined. Like, how dare you, right? You don't have access. You don't have access to this scope, right, from the outside. So we can't do anything about this from the outside, right? But we can actually use higher order functions to get access to water bottles, and I'll show you how that works. Okay, so I'll say like not okay. Okay. But what is okay? So what I'm going to do is I'm going to return a function. Okay? And this function is going to return water bottles. I know this is just what, but we have a function that will return water bottles. So here's my question to you. This function, does this function have access to this variable? Yes, it does, because it's inside of it, that function. So since we have a function that actually has access to this, like I'm taking that function that has access and I'm giving that to someone else. I'm like spitting it back out so that someone else can take this function which has that access encapsulated inside of it. So it's almost like a hack, right? It's almost like a mole or something. Like I have this mole, this insider that does legally have access to water bottles. I'm just like gonna give that to someone else who normally wouldn't have access. And so I'm gonna store this function in a result. Okay? And this is gonna be car. And so if I console log result, what is it gonna be? It's gonna be this function itself. Okay, it's just gonna be a function. Okay? Just a function. So, okay, let's call this function. Okay? and we get 0, right? I know this is like very anticlimactic. You're like, this is what? This is so dumb. But this is actually very climactic. What we just did was we were able to access a variable that would otherwise be out of our scope. Like, we shouldn't be able to do this, but we somehow got to see inside of this function and see what water bottles is holding onto. Now here's where this gets interesting. This function right now is simply like an observer, right? It like observes what water bottle is, sort of like leaks out information, right? It's like this is what water bottles is right now. But we can have this function also update the number, right? So if I'm looking at this function, right? If I'm looking at this function, what is this function doing? It's adding 1 to water bottles, which is it allowed to do that? Yes, it is, because it's in the scope. So this is going to become 1, and it's going to return the result of that. So whenever we call this function, it's going to add to water bottles. Okay? 1. And 4. Again, very anticlimactic looking, but we literally just incremented. We like edited the value of this from out here, from the global scope. This should be totally illegal. How are we able to do that? We used an insider, a function within this larger function that does have access to changing what water bottles is, and then we just pass that out to someone else. It's almost like it's like a portal that was created, right? So like from the outside world, I can't look in here. So we have an insider that can look in here, and then we give that insider to the outside world. This must be what hackers use. It honestly, it is how it works, right? I don't know if you saw like the Twitter hack. First of all, I can't believe the Twitter hack happened. Like, if you just think about how much worse it could have been, like, really you had, I think it was like what, 4 or 5 of the richest people in the world, and all these politicians and all these organizations were hacked. Like, can you imagine if they like said something like, I don't know, like that, like incited violence, or I don't know, it could have been really bad. But how did they get access? Right? They had an insider. Because from the outside, I can't just do whatever to like tweet on their behalf. So they accessed an administrator, someone who works at Twitter, right? And someone who works at Twitter can edit, right, all their accounts. And so that's what you hijack. You don't try to like somehow magically like guess everyone's passwords. That's just like too hard. That's unrealistic. Mm, yeah. So each time we run this function, right, we're incrementing water bottles. We're adding this one. So I'm gonna say console log added a water bottle, and then water bottles. Water bottles. So every time I run this function, first of all, let me put another thing up here just so we make it crystal clear that this outer function only runs once. Like starting engine, okay? So we start the engine, and notice this only happens once because we only run car once, and that's run here. So when I execute car, we start the engine, we initialize water bottles to 0, and then we return this function. We don't call this function, we return this function, which can do all this stuff, to result. So now we basically like given someone like this remote controlled ability to just like randomly like add water bottles into our car. And every time we run that, we press the button on this remote, we're running this function. We're not restarting the car engine. We're just running this function. And so this function adds one to water bottles, console logs added water bottle, right? So that's added to 0, and then we return the result of that. So I mean, I can also like save this in another variable, right? Let like num equals, and then this number would be whatever this function returns, which is the number 1. But I'm not doing. I'm just like calling the function, and so every time I run this function, I'm just like basically rerunning this function, and so I just keep adding, and it keeps console logging every time I run the function. Is this sort of what you were looking for? Exactly. Yeah, the plus plus will add 1 and reassign to what to the original variable. Sorry, can you say that one more time? Correct. Exactly. Exactly. This inner function has access to everything in here. Exactly. It's our insider. This is our insider. And as such, we can, like, the more power our insider has, the more power that we get to leverage from the outside. So, to take this another level, let's say instead of just adding 1, why not control how many water balls get added? So this is going to take a number, and this is going to add that number to the number of water bottles. Okay, so when I'm putting the number in here, which function am I putting the number into? Am I putting it into car, or am I putting it into result? Result. That's what this function is, right? Car is this function out here, and that doesn't take any numbers. This result is this function. So now I can like literally just decide. I can put in 2, 5, or 1, and maybe like 1. So I'm like slowly I'm like getting even more and more power, right? It's like I'm able to do a lot more like sophisticated manipulations, again, to a variable that is otherwise outside of my control, somehow from the global scope, while I'm outside of the function. If you run car in between results, does it reset the count? Amazing question. Amazing question. Yes and no. Yes and no. So the question was, if I run car here, right, is this going to reset the water bottles to 0? And the answer is yes. We will start the engine, and we will set the water bottles to 0. Okay, but what the engine that we start is actually going to be that of a different car. So I'll show you what I mean. And let's just keep these at 1. So we see starting engine. So that's for this car right here. Set water bottles to 0, and then I start adding to the water bottles, right? So I add 1. That's from here, and then I start the engine again. So starting the engine. Okay? And just to be absolutely clear, right? I'm going to say starting the engine and then the number of water bottles here. So starting the engine, start at 0, add a water bottle, and I start the engine again and it's clearly 0. Right? It clearly gets like reset to 0. And yet this thing, when I add to 1, it actually like somehow magically remembers that it used to be 1 before. And goes to 2. The reason this is happening is because result refers to a very specific instance of this car. So this would be like maybe like a Toyota. Okay? And when I do this, yes, I am starting a car and I am setting it to 0, but this is another car, right? I'll say Honda. And then what I'm going to do is I can say Honda, and let's say 10. So we added a water bottle to Honda. And what do you notice? It goes from 0 to 10. It doesn't like add to 4. Right? It doesn't like get intertwined with Toyota and it's like, oh, Toyota had 4, so I'm gonna add 10 to that. It's like its own car. It's its own separate universe. And I can still keep adding to Toyota. I can like add like another 2 to Toyota. And Toyota's at 6. And I can add to Honda, let's say another 5. And Honda's at 15. So they somehow like know to keep track of themselves. Exactly. We have 2 separate results, 2 separate functions. And slowly we're creeping into why this is just like one of the most powerful things. I think this is like way more powerful than recursion, to be honest. This is probably one of the most important concepts in JavaScript. Recursion is the worst. Yeah, it's pretty bad. It's pretty bad. Okay, let's actually. I like this segue. I like this segue. Because we can actually. I'm gonna. We'll keep this because I like to keep like the step-by-step kind of path here. So let's do 2 Toyotas. Let's have Honda start at like 3 and then add another 3. Toyota's can add another 1, just so it's like a little bit easier to follow. Maybe like 2s. 2, and we'll do like 5 and 5. Okay, so what I'm going to do is we are going to pass in a function, or sorry, pass in an argument to car. So far, this outer higher order function, we never like pass in any arguments into, right? In what situation would it be helpful to pass in a value here? When you know that you're gonna have multiple cars. Okay? So here I'm gonna put like a make. Right? Or why did I push me there? So what it's called? Is it a make or a model? Like if I say I have a Toyota, is that a make or a model? Or is that neither? Both? Okay. So what we're gonna do here is starting engine. So starting up my make. Okay. I think make is the brand. Okay, cool. So let's just kill Honda for now. Let's do Toyota. Okay. And let's do this. What the? Okay. Ooh, starting up my undefined. Starting up my make. Why is this undefined? Yes, in the car, not into Toyota, right? And so we're gonna call this Toyota. Okay. Starting up my Toyota. Okay. And here's the magic. Okay. Well, first of all, let me also start up my Honda. Okay. At the end. So starting up my Honda. Here's the crazy part. This function, we can have it remember what make it was initialized with. So we can like basically like bake in a make. So what I'm gonna say is instead of just added a water bottle, we'll say added a water bottle to make, and then we're gonna put in the bottles. And I'm gonna rename this. Call it like bottles. Okay. So let's think about this for a second. So make comes in as Toyota. I'm gonna say starting up my Toyota, right? That's why we see this. That makes sense. And then this function is going to return. Sorry, this is going to return a function into Toyota. Toyota is executed. Okay. And so we add, and then we see console log add a water bottle to make. Now, does this have access to this by this point? Yes, because it's in scope. And what is the make? It's Toyota, right? So say starting up my Toyota, added a water bottle to Toyota 246. And it specifies where we've added the water bottle to Toyota specifically. And then we start up another car called Honda. Okay? And with Honda, let me add a 1 here. What do we see? We see added a water bottle to the Honda. Because when I generate a new car and I pass in Honda, now it's a separate car. Think of it as like, I know it's the same function, and that's what's really confusing. Think of it as like a separate function. And this is just Honda now. And it's going to say starting up my Honda. And then when I add a water bottle, it'll say added a water bottle to the Honda. Like that's what this function is. This function is now forever associated with Honda. I can never like get this to like refer to Toyota ever, right? And if I add another one to the Honda, we get this. It's like a template. It's very much like a template. Exactly what, this is a template for a car. And then this is a template for adding water bottles to that car and only that car. So let's say this is 3 or sorry. So I'm gonna do this Honda twice, and oh, it's hanging. But if I put a Toyota and I put another 2 here, it's going to remember what the Toyota was at. If this runs, here it is. So I put Toyota after I started off the Honda, and the Toyota remembered which one to put it on. Okay, and let's do a Honda. Let's add like 10 to Honda. Boom. And we basically just have these like separate universes that can never like get intertwined. And of course, we can have another car, right? We'll say Tesla. Starting up my Tesla. Okay, Tesla, start with like 4, add a water bottle Tesla. And Toyota's still like alive and well, right? So Toyota went from 8 to 10. Yes. So yeah, so like where is the variable being stored? So sorry, I totally forgot to say that this concept of leveraging a function to control, leveraging a higher order function to control something that's outside of our scope, this is called a closure. This is called a closure. Okay, so a closure allows you to access a variable that is outside of normal access, that is, let's see, outside the scope of standard access, by leveraging higher order functions. more specifically, it's like use leverages a oh fuck leverages an inner function that has access to the outer function's variables and returns that inner function. So it's sort of like a mole, right? Slash insider. Okay, this is literally like one of the most advanced topics of JavaScript, period. Closure. And if you Google this and like look for like blog posts, there's a lot of like YouTube videos and stuff that explain this. Every single thing has like a different like kind of way of visualizing it and expressing it, and I would say 99% of it just doesn't make sense. Um, but this is basically what it is. Okay, from out here, I there's no way I can just do this bottles like plus plus, right, or like bottles plus equals 2. That's impossible. But I can leverage something called closure to make that possible, right? It's a little bit indirect, it's a little sneaky, but I basically have this function return another function. This has valid access into this stuff, right? Like this can legally access it because it is inside of the function, so it does follow the rules of scope. And then this function is returned and stored into Toyota. And at this point, to sort of like answer your original question, we have this function that's basically bound. It's basically bound to this value Toyota, and like that sort of like initialization of Toyota, and it will just forever be bound to that value, sort of baked in. If car has variables that aren't mentioned in Toyota, does Toyota also have access to those, or just the ones using Toyota? Great question. Great question. Really like it. And I'll kind of repeat it. So actually, I'm gonna make it a little bit. Let's back up because that function is getting really big. Let's say function like car, right? Let's just let bottles equals 0, and let people equals 2. And I have a return. I'm returning a function, okay? And this function is going to console log the number of bottles. Car. I'm gonna say car. I guess like my func. I'm gonna say car. I'm gonna call the func. And we get the number of bottles is 0, right? And so Alice's question is, using closure, right? Does this function also have access to people? And from out here, can I access people? Right? Or like let I don't know, gas tank equals, I don't know, 70%, right? Can I access people and gas tank when I somehow using by leveraging this mole that I have? And the answer is no. The answer is no. So this inner function, so basically, let's think about it this way. The degree of access you enable is determined by what is allowed by the inner function being returned. So basically, when you define this inner function, you are the decider. You get to decide how much access the outsider gets to have. And what do you recognize about this function? Like, what are we seeing? We only have access to bottles. So like, yes, I have an insider, but my insider only has access to bottles. But it can't tell me anything about people or gas tank. So in a sense, this is almost like private variables, because I just can't access it from the outside, right? And even the stuff that you can access, so like we can access bottles, I see that it's 0, right? But it's what we call like read-only access, in the sense that, yes, I see that it's 0, but that is very different from being able to change right? From being able to like make this 1 or make this 2, right? This function doesn't allow that. This function isn't doing like a bottles plus plus or something. And so really there's a lot of power in defining this function and what is allowed by the inner function. You decide. And if in here you decide, okay, you're also going to console log the people and also the gas tank, right? Then from out here, right, you can see those things, but you can only see those things because this inner function has allowed for that, right? Does that make sense? So you sort of set up your own boundaries. And this is incredibly important. This is incredibly important. This is such an advanced concept. Like this is even beyond like today's discussion. But if you think about like what you allow your users to do, you can only allow them to do certain things. So let's see. Let's say there's like an app where you can do like voting or something, right? An app that allows you to vote. Like you should design your function, right? You should design your function to be the function that's returned to only allow for a single vote. So if someone like calls that inner function, they just like it just adds a 1 vote to the system. So you're restraining. So you give them you do give them some access. You do allow them to add to the vote, but you do not allow them to change the vote to whatever number they want, right? Like, just say vote equals 2,000. Just replace the vote. That's too much access. So there's like figuring out how much, like what's the right amount, is a lot of I guess like the development cycle and stuff you think about. It's loading here. Cool. Cool. Awesome. Now let's let's say there's a scenario where you actually do want to be able to change all of these things. It's pretty actually. I won't go into that. I don't think and that's overkill. Are there any questions? I know this was a really weird concept. It's gonna take a while to like really get. Yeah, you mean in like the workshop, or oh okay, yeah, let's do that. Okay, I'm gonna make everything available. So we have a few. There's actually a lot here, and definitely don't feel like you need to finish this. You probably won't. Builder. Okay. I'm trying to think if there's anything that's easier. Let's try it. Okay. So builder, right, will be a function that takes the name of a state as a parameter. And builder should return a new function that takes the price of an item and returns the correct final price of the item given the following. If New York, we charge 3% for shipping, 4% sales tax. If New Jersey, charge 5% for shipping and 6.625% for sales tax. Okay, so I know that's a lot of information, right? But we're building a higher order function that is biller, or I guess it should be builder, so it's actually a typo. So builder takes the name of a state as a parameter. So we just put in a string here. This is sort of like I just put in Toyota, and now I have this function that like will only manipulate Toyota. So we have this thing will return a function that will calculate the taxes for that state and that state only for New York. So this function returns another function, stores it into here. How do we know that this New York builder is a function? Because you can call it. So you literally just call this function, pass in 100, and it calculates what that should, I guess like what this should cost based on the sales tax in New York. And for New Jersey, is New Jersey really higher? That's crazy. It's definitely, I don't think that's true, right? Anyway, so New Jersey takes in 100 and gives you a different tax. Okay? Because this biller, yes, it's the same biller here, but it got a different state. And so it basically spat back out a different function with different values in it that calculates. Yeah. Yeah, I don't think it's higher. Ample front traversal. What? Okay. So let's just call this builder. People specifically going to, yeah, right? Oops. Yeah, I'm in New Hampshire. 0% sales tax. 0. It's amazing. Live free or die. Okay. So function builder takes a state. Okay? And we know that this higher order function has to return a function, right? So just do this. Just return function. Boom. Like, you know you're gonna have to do something in here, right? And so sort of like, if I do like array dot for each, like I know a function is supposed to go in here, so just put that skeleton in here, right? And so like you don't have to like think about like from here, you at least you have the syntax right. It's really hard to like write the correct thing sort of in perfect order. So just have this written out. And then so the state comes into here. Okay, let's just focus on this first one. So state comes into here. So let me just console log like building biller for state. Building biller for New York, right? New York still says 8.875. Yeah, that's rough. Super rough. So we want to return a function, okay? Now, so this New York biller will be this function. Like this function will end up as New York biller. So what do you notice about this function? It takes an argument. So what line should we be preparing to take this argument? Where in this function should we 5? Exactly, because it's this function. Amazing. So this function is New York biller, and if it is New York biller, and New York biller is throwing 100 in here, then that's going into here. Okay, so this will be like price or something. So again, I'm just going to console log just to make sure I'm on the right track. Console log calculating for, and then price. Calculating for 100. Okay, great. So we have things like pretty hooked up. And now I just need to return this thing. Right? So I basically need to do 3% sales tax and shipping tax or whatever. So there's actually a few ways to do this. So we have like New York sales tax, New York shipping tax, and it's same for New Jersey and same for New Jersey. So we can do something like this. If state is New York, right? Because it might not be, but if the state is New York, I want to return the price, which is 100, okay, times, I guess 1.03 times 1.04, okay, times 1.03 times 1.04, okay. And that's really it. That's really it. For New York at least. Yeah. Hmm. Yeah. Exactly. Like it's actually a pretty weird setup that we just have to like hard code this here. But yeah, the builder should like be sort of like unopinionated and it should just take, right? Like um the sales and then shipping or whatever, taxes respectively. And then we should just like use that, right? Totally. Great observation. Um so if we do the same thing for New Jersey, right? It won't quite work yet. So we get building biller for New Jersey, and we're calculating for 100 because we do pass in 100 to New Jersey biller, right? Which is this function, okay? Um, but it doesn't pass this, right? Because state right here was New Jersey because we're building for New Jersey, right? So this if statement never hits. So we just need if state is New Jersey, return price times, I guess, this thing. Like this. And I'm going to get rid of this. And I know this looks weird, but that's basically what they wanted. This is what they wanted. So if I were to just do New York, right? I can let's console log 100, 200, and 300. Okay. And then for New Jersey, the same thing. This would be New Jersey biller. And 100, 200, and 300. So this is how 100, 200, 300 converts to New Jersey, and this is how it converts to New York. Okay, so I guess like if we were to tie this back to the lecture, really what we're doing is I'm leveraging this higher order function to get another function out, and this function will be like my go-to for calculating New York tax. And so now I have this like tool, I have this like helper, right, that calculates only New York taxes for me. And then this one only does it for New Jersey. So it's like two separate tools, I guess. So first I'm gonna check if this like passes the test, and if it does, I'm gonna show you like sort of a neater way to think about this, or another way to think about this. Cool. So another way to think about this is do something a little fancier. So what we're going to do is if state is New York, we do this. If state is New Jersey, we do this, right? But we can sort of like we can organize it a little bit differently, and basically treat New York and New Jersey as keys into an object, as keys into an object. And so, what do I mean by that? I can basically have an object that looks like this, right? I can have an object that's New York, right? That's an object. And then this will have shipping. Is it shipping and sales, or I guess it doesn't really matter, but shipping, yeah, shipping and sales. So shipping is 1.03, sales is 1.04, and then New Jersey shipping is 1.05, and sales is 6625. So I have this object, and now what I can do is I can do object bracket the state will give me another object for that state, right? Like a New York specific shipping and sales, figure. So if I do this object dot shipping, right? then I get 1.03. If I do this object dot sales, then we get 1.04, right? And then we can use New Jersey as another key into this object, right? This string is just a key. So well, first I'm gonna just move this up here as like an example. But then what I'm gonna do is I'm going to take this into here. Like this. And why does this look weird? I guess this is really called taxes, right? So how do I do this? Instead of doing this, what I'm going to do is I'm going to say const shipping is going to be taxes bracket New York just state dot shipping. And then the same thing for sales. So this right here is going to be 1.03. This right here is going to be 1.04. And now I can just return price times shipping times sales. Cool. So this is for New York. So what we did was we created this. I know this seems like more work, right? And it sort of is. But we basically have this nice feature where New York comes into here, right? And the price is 100. Okay. And whenever I try to look it up, I basically have this table. It's like my lookup table. And so the taxes using the key that they gave me, which is New York. So I look in here and I do that thing dot shipping is 1.03. And that thing dot sales is 1.04. And then what's cool about this is there's no like if statement anymore, right? Before we had like if New York, if New Jersey. Why don't we need an if statement anymore? Because if this is New Jersey, it's going to use that as the key, right? New Jersey, the state, comes into here, and now it looks up on the New Jersey side of things. So we don't need the if statement anymore. You can, but you want to be careful because shipping, like at this point, you would actually have to make it in a string, like this. The reason I didn't put this in a string is because this is a variable that represents a string already. But shipping, if I don't put strings around it, then it's going to look for a variable called shipping, and we don't have a variable called shipping anywhere, right? So we would have to do this, which is fine. Did that answer your question? Cool. And then we got, would it still work if you type lowercase in narrate? So great question, it wouldn't. If I do ny, this cannot read property shipping undefined. We get this crazy like scary thing, and that's because it looks for a new a lowercase ny key here, and that doesn't exist. That's undefined, and I try to do that undefined dot shipping, and we cannot read shipping of undefined. So what we can do is when this is actually we could probably do it up here. So when this is initialized, I say state equals state dot to uppercase. So immediately just uppercase it right when we start. Cool. Another cool property about this is this object no longer needs to be in here. So this object, right? There are no variables in here that depend on price or state, right? You don't see state being used in here. You don't see price being used in here. And whenever you have a situation like that, you can actually just move that up outside of the function. Or you could put this like in here, like outside of the inner function, but like in the larger function. That's totally fine too. but this allows for a really nice cleanup of this function here. Totally. For sure, yeah. And you know, as you'll see, right, there's more than just like something bad that they can type in. So they could do like NYC, right? That doesn't super help because even if I uppercase NYC, it doesn't work, right? So a way we can kind of solve for this is like we can detect whether they're doing something invalid off the bat in this function, not even in this function, right? We can, like right here where this is yelling at us, that's actually yelling at us here once I start to like use the inner function, but the outer function can detect it before the inner function even starts. And so what we can do is first we uppercase it and then we check whether this thing, whether this, I guess, whether this state exists in here, right? So if the state is not in the taxes, and I know this is like very confusing. There's no other way to do this. You have to do this, which I hate. I just hate it. But this is the only way you can say if this key is not in this object. I wish you could do like this or something if it's not in, but you just have to do like this, which is really annoying. So if the state provided is not there, then we can return instead of this function, right? We can return like, or I can return here and I can just error. We'll say like error to console.error or something. We'll say like say state is not a valid state. NYC is not a valid state, right? And so this fails here. So there's like, yeah, you can keep adding to the functionality, keep making it better and better and safer and safer. Cool. All right, it's 4:13, super late.